Wissenschaft fürs Wohnzimmer.
Einen wunderschönen Abend. Good evening to all of you out there for joining us at episode 177 for this episode of Wissenschaft fürs Wohnzimmer, Science for the Living Room. As you noticed, today's English and it's not German. I hope that's okay for you. But it'll be great. I hope so, at least. My name is Björn Zuko, and I'm working at the Alfred-Wegener-Institute for Polar Marine Research in the marine bioeconomy and trying to make the food from tomorrow from the sea as sustainable as possible. And this is brought to you by the Aves for Future, which is a subgroup of the Scientists for Future aiming at more science communication, and it consists only of members of the Alfred-Wegener Institute for Polar and Marine Research. And as always, I'm not here alone. I'm with Joseane Marques from Brazil, who's currently in Oldenburg, but she will tell you more about that in a bit. Joseane, it's up to you.
Hi, my name is Yasmin. I work at the same institute as Björn at the Alfred-Wegener-Institute in Bremerhaven. I'm a doctoral student and I'm working with Antarctic microalgae. And if you like this episode, please give us a like and share it with all of your friends, and also subscribe to our channel so you won't miss any episodes anymore. And after that, I'm giving to Melanie.
Yes, hello. Also from my side, I'm Melanie. I'm a PhD candidate at the Helmholtz Institute for Functional Marine Biodiversity, and I'm working there in biodiversity theory and try to understand food webs a little bit better. If you have any questions during the talk, you can always leave them in the chat and we will ask them on your behalf at the end of the talk. Since we are mostly German-speaking, you can also leave questions in German and English, of course, as well, but also in Spanish or Portuguese if you like. And with that, the stage is yours, or the stream is yours. Joseane, please.
Okay. Is it working? Okay, so thanks for having me here, guys. Thanks, Yasmin, for reaching out and inviting me. Well, who am I and how I got here, right? So right now I am a postdoc at the HIFMB, the Helmholtz Institute for Functional Marine Biodiversity, which is co-founded by Avi and the University of Oldenburg, and it's mostly interested in marine biodiversity research. What I'm doing specifically is to look into how coral reefs reassemble or recover after climate change. And I'm lucky enough to be part of a bigger group inside the HIFMB called Marine Conservation, led by Professor Eliana Bams. So here's just the pretty faces of my super nice, smart, and diverse group. But how does it all started, right? How did I become a scientist? How did I got to Germany? So I was born and raised in a small town in the countryside of Brazil. You can see in the map. It was very far. It was like 570 kilometers from the closest ocean site. And I could barely swim, and I never saw the ocean. But I decided I would be a marine scientist. And I was very stubborn, and I fight with everyone in my family. And eventually I managed to move to the coast of Paraná in the south. So south of my market star, it's this state, and where I did my bachelor's in oceanography. And later I went even more south to do my master's and my PhD in biological oceanography. And the fun thing is, although I was right there, deep in the south of Brazil, my research, my field work was in the Northeast, lucky me, in the state of Bahia, where I snorkeled for the first time and I fell in love with corals and coral reefs. And now I want to make all of you fall in love with them as well. What are even coral reefs, right? We don't have them in Germany. I'm sorry. I'm also sad about that. Think about magical underwater cities under the waves, vibrant and colorful. So these underwater cities are home to millions of tiny architects and very busy neighborhoods. I hope if you don't know what I mean, you watched Finding Nemo. That's the type of underwater city I'm talking about. It's gorgeous. But who builds this city, right? It's who are the builders. So it's an animal I know it's shocking. It looks like a rock, it looks like a plant, but it's an animal that belongs to a group called cnidarians. So they are close relative to jellyfish and sea anemones. Here in this photo, you can see a bunch of little mouths, right, with the tentacles. Each one is a coral polyp. It's one individual. And then they clone themselves and they start to grow and they produce calcium carbonate, which means the more they grow up and up, they leave this bed of calcium carbonate between them. And they grow enough until they become a colony, like this one in the photo you're seeing. And that's how they built the coral reef, the underwater cities, which is basically a living structure made by many colonies of different species of corals growing together layer by layer, stacking up their skeletons to build the structure. And then these structures, as you can see in the photo, they have many different forms and morphology. So they attract thousands of marine species because they are good nurseries and they are good like to protect themselves from predators. But it's important to tell you that corals, they may be the main stars of the reef, but without the silent work of many other organisms, the stage would collapse. For example, the glue and the cement of the reef are called calcifying algae. So algae that produces also calcium carbonate. And these silent workers, they stabilize like bricks loose in the reef. They put the pieces together, and they are also good to anchor the corals to the floor, help them to anchor to the floor, and protect them from being carried away by waves and currents. But one of the most important jobs of these hidden workers of our underwater cities is because they create a nursery space. They give baby corals a place to settle and grow. In this figure here, you can see this pink little thing on the floor. That's the calcifying algae, the type that we call CCA. And what they do, you know, when you're flying, you're taking an airplane and you have those workers from the airport with signs of light saying, yes, go up or go down. It's something like this. They send signals to the water to tell the coral larvae, hey, here's good, come up, come down, grow here. So, by the way, in case you want to know more specifically about this silent work, I suggest you to contact my colleague Abigail Turner. So yes, this means that it's very important that we understand who are the main builders of the reef, the corals, but that to protect this ecosystem, these cities, you need to also take care of all the other hidden players. But why do we care? Why are reefs important? They are not just beautiful ecosystems. They are home for 1/4 of all the marine species. It's a lot biodiversity. And they also protect many people, many islands, many countries from the waves and storms because they create like a shelter. And there are also potential medicines. There are many pharmaceuticals and drugs and medicines that you can get from animals that live in the reef. And also, they provide jobs and food for millions and millions of people worldwide. So for many places in the world, coral reefs are very important. And even here in Germany, where we don't have any coral reefs, you may need a medicine that came from an animal or a plant from the reef. Here in this map, you can see where you can find these underwater cities. In red, you have the warm water. In blue, you have the cold water underwater cities. So in this video, that is part of the project of my other colleague, Zerine, you can see the deep sea or cold water underwater cities. These amazing ecosystems are very far away from the land, and they're very deep, so it's much more difficult to study them. And although they are also very important and beautiful, in this whole talk, I'm gonna only be talking to you about the warm water shallow underwater cities or the warm water coral reefs. Well, despite being amazing, our underwater cities are in danger. I'm sure that most of you already heard about global coral bleaching. So because we are having so many heat waves, the corals around the world are bleaching and dying. But there are other stressors that are also putting these cities in danger, at risk, and we don't talk enough about them. Like, for example, pollution. I'm sorry for this big test. What's important here is, according to the United Nations, pollution is the introduction by man, by society, directly or indirectly, of substances, materials, or energy to the marine environment, resulting in harm. So anything made by humans that ends up in the sea and causes harm is considered pollution. And most of the countries, they use this definition in their law system to decide how to protect or manage the marine ecosystems. And here, it's important also to tell you the difference between contamination and pollution. So contamination is when a substance, let's say a pharmaceutical or microplastics, they are present in a place where they're not supposed to be in natural conditions. Or like for example, some metals, they are supposed to be like copper, they're supposed to be in the sea, but in small concentrations. So when you have too much, it becomes bad, it becomes a contaminant. You know, the difference between a medicine and a poison is the dose, is this idea. And then this works as a red flag for us. When you see a microplastic or a metal or whatever in a place where it shouldn't, or in a dose that it's not normal, red flag, that's a contaminant, let's pay attention. But only a contaminant that causes proven bad effects that harm the environment or humans are considered pollution. So only when you can prove that this or that chemical or microplastic is bad for humans or the sea is that we can do management, that governments or environmental agencies or the society can actually do something about it. And what are the main types of pollution that we already know well that occurs often in our underwater cities? Considering substances and materials, here is a list of different substances that are very common in reefs. Microplastics, metals, too much sediment, too much nutrient, pharmaceuticals. I'm gonna only talk about a few that I have more experience, also because it's too much, right? I don't wanna make you bored. For example, let's look into copper. Copper, it's an essential metal. What does it mean? It means that all of us, our cells, need copper to function well. However, if you have too much, it starts to be bad, right? The difference between the medicine and the poison. And we use copper a lot in many industrial activities, in paints that we use in ships, for example. There is a lot of copper that arrives in the sea through the rivers, through the waste of our houses. So sadly, it's a very common pollutant. In my past research, I checked what different concentrations of copper, so increasing levels of copper does with different animals or organisms from the reef. And what we see is that they grow less, they have higher bleaching or even oxidative damage in their DNA. And why is that? Because this metal, when it goes inside the cells, it messes up with everything. The proteins, the enzymes that our system needs to function well, it gets everything messed up. And you know that these reef organisms, they need to produce skeleton, right? They need to calcify. And when metals come into the cell, the system that builds the skeleton gets confused. It takes copper instead of calcium, instead of carbonate or things like that. So that's why you usually have less growth when the environment has copper. Another very common example is a herbicide called diron. So we use this in the crops to kill the weed. But when you get to the sea, it's gonna kill things we don't wanna kill. Like for example, calcifying algae. So this little figure here on the left is a calcifying green algae. And on the right, you have a coral. And in these graphs, what you need to pay attention is that, like from left to right, you have higher dose of the diuron. And from bottom to top, you have photosynthesis. So you can see that when you have more and more diuron, the photosynthesis is going down in most of the organisms. So that's how this common pollutant is affecting species from the sea. Opa. Okay, now I cannot, we did not test this.
Once more, you were already there. Maybe escape. I'm just guessing here.
Ah,
yeah, there you go.
Oh my God. Okay, hold on, let me erase all of it.
So while Joseane is doing this, so if photosynthesis goes down, obviously the growth of the animal goes down because this is how they produce their biomass. There you go.
Okay, I'm back on the stage. So I brought back the list of common pollutants in the reef to tell you what they have in common, all of them. Okay, one messes up with calcification. The other messes up with the photosynthesis. That's what scientists do, like we keep checking what happens inside the organism, inside the cell, when you have these or that contaminant. But what matters is their source. Most of these common ones, they're coming from the land. That's how they reach the coral reefs. And this is important because it tells us that to protect the sea, the coral reefs, or any underwater city, we need to start from the land. Okay. In this other example, I brought a map from Brazil, but it's a case that you can see in reefs all over the world. So you have here the map, and then here you have on the right like a zoom in. So we were monitoring reefs, like sectors, from 1 to 4. So you can see from close to the land to far from the land. And then what we find? Closer to the land, a lot of more copper, lead, a lot of fecal steroids, which means poop, and bacteria, and many contaminants working at the same time. So imagine if copper alone or diuron alone, herbicide, messes up with the cells, imagine when all of these things are working together. And that's what we have in most of the reefs around the world. All of these contaminants acting at the same time to cause harm. So in most cases, the far away you are from the land, the corals are healthier and the reef in general. So bringing up again the message that we need to start on the continent to protect the sea. And remember when I showed you the definition of UN about what is pollution? So it's not only about materials and substances, it's also about energy. So for example, sound. We have sound pollution in the reefs. We're just not studying it. We don't have enough information about that. What I want to bring to you is the case of light pollution. So in this figure here, you can look on the top figure, you can see normal dark, the moon is shining, and the reef is working well. The reef organisms, they don't have a clock, they don't have alarm. How do they know what they have to do, what time they have to do? They know because of like internal biological clocks. And these internal clocks, they need the right amount of daylight and darkness. And they also can sense the moon. So this light and dark, it's what tell the animals of the reef how to behave and what time to reproduce and everything else. It's their clock. But you can imagine by looking at the bottom, the image on the bottom, that if you have a lot of boats, platforms in the middle of the ocean with a lot of light, and cities with too much light at night, artificial light, then the coral, they don't have, like, their clock is not working anymore. They get super confused. So they don't know what to do. And you can imagine what? You're going to have harm. And this is a chance to advertise another of my colleagues, Isabel. She's working on how the corals, they can sense the moonlight. So, they don't have eyes, they don't have ears. How do they know, right? So she's studying how the corals can feel the moonlight and how these signals of the moonlight can change the morphology and the reproduction of the corals. And the reproduction is something very important here because let's say that light doesn't affect corals. They grown up, they adult. I'm fine. But if it prevents reproduction, then the community, the population will not continue, right? So that's the importance of the moonlight in the reproduction. So the moonlight is what says, hey guys, it's showtime, let's reproduce. And then the corals feel it, and then they start something we call mass coral spawning. So you can imagine that if the moonlight is messed up with all the artificial light, how will the coral know when it's time to reproduce? They won't. They get confused. And actually, in this video, it's part of a project that shows that the fish from coral reefs are also confused by the artificial light. So in this project, we have under the water different tables. Some tables were normal, no artificial light, and some tables have artificial white light, some tables artificial yellow light. And then we saw what happened to the coral, if the coral is getting sick. And we saw what happens with the fish that lives around the coral colonies. And we could see that the corals, they're set. Okay, how can I explain this? You're tired, you want to sleep, but then you cannot close your window. There is this light from ambulances and from the street and doesn't let you sleep. You're going to feel sick, right? You're going to be moody, you're going to be angry, and in the long term, you're going to feel sick. So that's what we see happening with the corals. And the fish as well, their brain has damage. That's what we could find. And their behavior around the corals is very different. And this is important because in the reef, it's all about interactions between species. So you need that the coral is healthy, but you need that the other animals are also healthy to make the ecosystem, the underwater city, function as a whole. It doesn't matter if you can still build a building in your system. You need that the neighbors can live well there. So that's something very important about these ecosystems. Every time you are trying to prove that a contaminant is a pollutant, it's important to not only see what happens with the coral, with the builder, but with all other members of your underwater city. And another important thing about the light pollution is it's kind of new. Let's put it that way. Remember, I told you to do management, to have a law helping you to decrease pollution. You need to prove that this contaminant is causing harm. So only a few years ago, the scientists started to prove that it's not only a contamination of too much light, it's pollution. It's causing harm to many different animals. So it's not in the legislation well, and we really hope that with the science results, we can make a dark sky legislation in reefs around the world. And if you ever build a house close to the coast in a place with coral reefs, please choose wisely which type of lights you would use. So yeah, that's what I was trying to say. It's very important to know that a contaminant is there, but you need to prove that they harm the environment in order to have the community, the industry, and the government working together to manage that pollution. And one of the tools we have to manage pollution, it's called water quality guidelines. So experts or scientists, they show to environmental agencies that, hey, this contaminant in this level is bad. So make a rule and don't let the industries or the ships or the human society dump too much of this contaminant in the water. So that's how it works. And it's important that science citizen scientists and monitoring programs from different countries. They are always up to date on what is old school and what is new school contaminants. So we know metals are a problem for years, but we have to be aware that, for example, light pollution can also be bad. So guys, let's pay attention to this. Let's maybe change the water quality guidelines and have these new pollutants on the book. And another issue is climate change. So we had very hot days, right? In the past days. So some people suffer. It's tough to be so hot. Imagine if you have to deal with that heat and be poisoned at the same time. It would be terrible, right? And that's what happened with the corals, because you have climate change, heat waves causing bleaching, and in many other places you also have pollution, poisoning them. So it's too much. In this graph, what's important for you to see is from bottom to top, you have a stress index. So the higher the number, more stressed the coral is. On the bottom, you have copper. So 0 addition, just normal level, or addition of 5. This addition is okay according to the water quality guidelines. It means it's okay. Nothing will happen if you increase a bit. And you can see my stress index, the gray bar, is increasing, but it's not too much. So still we are fine. But then when you combine in blue ocean acidification, in red heat wave warming, or in purple, even worse, ocean acidification and warming, which are things that will happen together when climate change hits us. And then if you combine this even with copper, then the heat stress or the stress index goes super high. You can see here the purple on the right. It's so much higher than all the other levels. It's showing us that, like us, the corals don't like to be in too much heat and poisoned at the same time. And this is also important for the water quality guidelines. We, as citizens, we have to push the governments and the environmental agencies to update the water quality guidelines and make climate adjusted ones. It means that pollution is there. We need to pay attention to the level because it can be very bad for the marine ecosystem. But once climate change comes, the same level of pollution will be even worse. It will cause even more stress. So we need to be aware of this. And here I brought again the vision of the Marine Conservation Group where I'm working, which is we want to see a world where reef building corals, they persist through this period of rapid climate change. However, if we don't update our water quality guidelines, if we don't make responsible choices regarding what we are doing with our waste and who we are electing, and if we don't have our eyes wide open for hidden pollutants, the corals, the whole ecosystem, they will not be able to face the climate change, even if we do coral restoration, even if we go to the field and find the corals that are super corals that are more resistant to heat, that's beautiful, but if they are poisoned by pollution, then it's gonna be harder for the ecosystem to recover from heat waves. So in this figure on the right, on the top, you have like a healthy coral reef. And then once they go through a heat wave, for example, they can even recover similar to what it was before, which is the figure on the left, or it can change completely. The reef cannot actually recover well, and then it becomes a very different ecosystem, for example, dominated by fleshy algae instead of corals, like on the right. And what we want is to make sure that even if heat waves comes, our coral reefs, our underwater cities, they will recover to similar levels as they were before. And of course, it's important to fight against climate change and have less CO2 in the atmosphere, but it's also in our hands to prevent local stressors and to decrease pollution so we can help the corals to deal with the rapid climate change. So one of my main take-home messages is protecting coral reefs begins inland, on farms, in the cities, how we manage our waste, how we manage our water. So in general, pollution management and reef conservation starts on the continent. And that's it. Feel free to contact me. Here's my email, and I hope you understood. You can make any questions. Thank you.
Perfect. Thank you so much, Joseane. That was what was brilliant. How you also put a bit of our lives in the coral's life and make us understand what the coral feel. Please just unshare the screen because now it's up to you out there. Please let us know any questions you might have because of this now to Joseane and leave it in our chat and we'll ask on your behalf those questions to Joseane. But in the meantime, while you have a bit of time to type, I'll let you know what's going to happen after our break. I just have to look around here because we'll have a summer break. Pronounced a summer break, but this is what you'll see after the summer break. The summer break will be over on the 21st of August, and we'll be talking about not yet built ship, but the new ice-breaking vessel Polarstern 2, which is the successor to our over 40-year-old Polarstern, our current basically way how to enter the Arctic and Antarctic in order to do science there. So let's see how this thing is gonna be built. Let's hear about what it is that it's different to the current one, how it's more sustainable, and how it's actually bringing us back and forth, and what other interesting features it has, and all those thoughts that went into the process of actually creating the most sustainable and most high-tech ship vessel out there for polar marine research is still able to break the ice. And now, back to you guys out there, back to you, Joseane. Melanie, is there any question in the chat already?
Yes, there were already some people quite interested in your talk, so thanks a lot for that. And we also have the first question from Uhau83. They say, interesting, I didn't know that deep water corals are colorful. I thought they wouldn't so deep down. Is there a reason for it?
This I'm gonna save for Zeverin's talk. So I can ask him and then we're gonna leave a short explanation in the chat later, but I'm hoping that he would make a full explanation for that. The deep sea corals, they don't have the zooxanthella, so I did not go into details about that, but the warm water corals, their colors are actually from the algae that lives in their tissue. And the deep sea corals, they don't have these algae, so it's a different process, but I'll leave it for him.
So we really have to convince him to come.
Mm-hmm.
Yasmina, are there more questions?
Yeah. I was just about to say that there was another one for you, Josie. Wissenmacht OH was asking, what do you think about the idea to restore dead reefs with more resilient species? Good or just creating a monoculture with little ecological value?
That's a very good question, and it's a discussion between the reef scientists as well. Yeah, what actually most of us we advocate for is that you need to have genetic diversity in the reef. So it's valid to bring more of the heat resistant for the restoration nurseries, let's say, but a coral that is resistant to heat may not be resistant to bacteria from human waste and many other types of diseases. So it's very dangerous to do an actual monoculture. So that's not really what we would recommend. We would recommend to keep, yes, bring the heat resistant ones because we need some coral to start off to recover. But we need to make sure to keep a minimal level of genetic diversity and avoid the monoculture.
Yeah, thank you.
Right, questions are pouring in, and I love it that we already have now somebody that we really have to have on the show. So if you like it, please leave a thumbs up, and then we go after him and get you all the info that you need on deep sea corals. Our third question is from Livia Oliveira. What is the consensus on sunscreens in the water? So as you know, I love surfing, so I find that a really interesting questions. I just happen to, I think, have not surfed over a living coral reef yet because they're all really far away and try to not fly so much, but I probably was close to one once. So what is the consensus on sunscreens in the water? Are there ones that are safe or it depends on location? Thanks for the talk and yeah, so.
That's a very good question. There is no consensus yet, actually. Many of the sunscreens that they say they are reef safe, when scientists do tests with them, they are not. We have a problem with tests to actually check if something is safe. So I will explain. We need standard tests, right? To make sure, is this safe, is this not? So usually, whatever we have in the water quality guidelines from the governments came from standard tests. And then the truth is, we don't have still yet a standard test for corals. And that's a critique from the reef scientists for the water quality guidelines, because they are based on tests with animals that don't look nothing like corals. So you need to do something like more tailored to the environment that you are working with. So because we don't have standard tests for corals yet, it's been very hard to find a consensus about these new products, like, for example, sunscreen. So yeah, no consensus yet. There are a few papers coming out. There is also a lot of effort. There is Peter Schupp's group in University of Oldenburg. They are also trying to make standardized toxicity tests, and including, if I'm not mistaken, with sunscreens. But yeah, sorry, not yet something we can rely on. We are working on that. We as reef scientists around the world.
And do you know how it's currently done then? So because I think there's on some sunscreens, I do remember that they have like a sign or symbol or something, but it's not like an international
accepted
code or so. Okay, so they do it themselves and they put it out there and you.
Yeah, I'm aware that some companies they are doing tests and they are reaching out to scientists. For example, I work with this NGO in Brazil about coral reef conservation, and some companies that produce sunscreens are currently trying to make a partnership with them to actually check this more properly. I'm not saying that all the sunscreens that has the reef safe are wrong. I'm just saying that because we don't have the standardized method yet, it's very hard to like say, yeah, for sure, that's good or that's not. So this is a work, this is under construction.
Okay, thank you so much for this very detailed answer.
And I really love it that we also have some questions from colleagues from our institute as well. But there's also another question from Bees. Do you plan to do more science communication? This is so needed in our world today. And can you talk a little about those plans for more outreach?
I do really like science communication and outreach, but since I'm only A1.1 level of German, it's very hard to do here. So I often give talks to Brazilian schools and things like this. Here I'm not yet ready, but the HIFMB and the Marine Conservation Group, we are planning some activities to talk more about coral reefs here in Germany.
Any dates yet?
I don't remember. We've been. I'm gonna send in the chat later. Isabel from my group, she's the main organizer of our outreach activities.
So
I just wanted to ask the same because I think it sounds really interesting. But maybe we can get one of your group for the Science Slam of the university next year. It's also really a lot of fun.
So as Bees asked this, is there any way, Melanie, as you're also sometimes involved in this, is there already something going on that you can hint to our viewers currently that are like from the area?
Right now, the only thing I'm involved in kind of science communication is there will be a project with a German children television series called Die Sendung mit der Maus. They always have these door opener days where kids can come in and see what we're working with and how it's like to be a scientist and learn something cool about marine science and also some of the stuff we are doing there. So that will be in October. I don't think there's anything planned before that, not as far as I know. But there are always news on our website as well. So if anything's coming up, we will also give announcements on our Blue Sky and Instagram pages.
Perfect. Thank you. And sorry for interrupting, Joseane. More questions?
I think from the chat right now we don't, but if you don't mind, I would have a question myself. It maybe circles a bit back to coral stress and maybe also relates a bit to the sunscreen question, because you've showed this stress index, I think it was called IBR or something. Because how do you measure this? Like, for example, I work with algae, and when I measure stress, it's usually a growth response, or I can see, oh, their photosynthesis is really not doing well. How do you do this in corals? And could this somehow be applied to the sunscreen problem? Just maybe a naive question from someone who has not much of a clue about corals.
So I chose to show you the IBR because I thought it was the easier, like, yeah, stress index. So it's called integrated biomarker response. So you actually measure a few endpoints from 3 to 7. And then you see how each one of them, like, for example, you have growth. So growth is increasing or decreasing compared to control. And you see photosynthesis and stress enzymes. You have to decide your endpoints, and they have to make sense. So for example, for metals, it makes sense that I check calcification related enzymes, for example. If it's diron, it makes sense that I focus on endpoints that are related to photosynthesis. And then you make a model to integrate everything, and then have one number. And then the higher the number, the higher the stress. But you need to decide your endpoints. It's just a way to integrate 7 graphs into one that says, yeah, they're well, they're not so well.
I see. Thanks a lot.
You're welcome.
So I think we're getting to the end. I don't see more questions here in the chat. So I may take the last question, I guess. I loved it how you talked about your love for the ocean, and I feel so much for it. Loving the ocean myself as well. Very often though, being more like in the cold water, as you can see there. But obviously, I was once blessed to be in Brazil, not twice, for project meetings with all the lovely folks. But coming to corals and your topic, the question that I had is with regard to climate change, pollution, and you named all these stressors. Let's have like 2 looks. One is that we like put proper management in place and keep up to speed. And if we go with the current levels, so that is reaching like 3 degrees Celsius plus minus by the end of the century. What's your fear? How will the coral reefs, that is the coral reefs that you are studying, not the deep water ones, but the shallow water ones, how many of those will potentially survive? Because there's different numbers out there in the good and the bad case. Let's start with the bad and end with the good, please.
You mean like if we do management and you just have climate change into the play?
No, if we do management and do fight climate change, and on the other hand, we disregard both.
Oh, if we
Or worst and
disregard
best
both,
case.
there will be nothing left, I would say. I mean, I like to say that reefs will be there. You know, like the coral reefs have been around for much longer than humans. So I would say there will be coral reefs. They will just look absolutely different than what we know today. And we don't know if they will provide the same ecosystem services. And I would say that no, because most of the species that they provide 3-dimensional complexity and then attracts the biodiversity, they will not, these ones would likely not survive. So if we disregard both, we're going to have, I would say, flat and poor, not interesting underwater cities. There will be something there, but not as we know now. And if we can manage pollution, at least, we can have a few more winners, a few more survivors. But in the end of the day, temperature, it's by far the worst stressor affecting corals as we know today.
Okay, thank you so much. That means for all of us out there, we stop the pollution in the cities and do our work to get our handprint right, to take as many people with us so that we hopefully will be able to see these marvelous, beautiful cities of the oceans. By saying this, thank you, Joseane, Melanie, Jasmine, all of you out there for joining us today for our English-speaking episode. Please share the word, like and subscribe. And we have our summer break now, and we'll be back with our Polarstern 2 ice-breaking research vessel being presented to you in our next episode on the 21st of August. Until then, please stay healthy, have a nice summer break as well, and then I hope to see you again when the jingle comes.
Wissenschaft fürs Wohnzimmer.